So, good day everyone! Our topic for today's video is all about pigeonhole principle, invariant principle, principle of mathematical induction, and argue by contradiction. First, we have pigeonhole principle. What is the pigeonhole principle? The pigeonhole principle states that if P items or pigeons are put into H or pigeonholes with P greater than H, then at least one pigeonhole must contain more than one item. So ayan, makikita natin sa picture na there are 9 pigeonholes. And kung bibilangin natin yung pigeons, there are 10. So it means magkakaroon tayo ng dalawang pigeons sa isang hole. So this pigeonhole contains more than one pigeon. So example problem. There are 3 pigeonholes and 4 pigeons. So we can evenly distribute a pigeon into each of the pigeonholes, leaving one pigeon left over. So, kung mapapansin natin, sabi nga kanina, there are 3 pigeonholes. Makikita natin dyan yung circle. And, meron tayong 4 na pigeons. So, i-distribute mo natin sila isa-isa and makikita natin na may maiiwan na isang pigeon. Then, the result is that at least one hole has 2 pigeons because the number of pigeons is greater than the number of holes. So, mapapansin natin dyan sa isang pigeonhole ay nagkaroon tayo ng dalawa. Dahil 4 nga ang ating pigeons and ang ating pigeonholes ay 3 lamang. So, try it on your own. There are 25 students in the class. Each student received an A, a B, or a C on their math test. Show that there are at least 9 students who received the same grade on the test. Here's the hint. Students are the pigeons and the grades are the holes. Yan. Makikita natin na meron tayong 25 students dyan. And tayong pigeonholes which is A, B, and C. So, here is how we see up the problem. We have 3 holes for the grades and 25 students. So, we can evenly distribute the students into each of the holes. And 1 student is remaining. So, gaya nung kanina, meron tayong naiwan na isa. So, dito naman, na-distribute natin siya ng by 8. So, 8 na 3, it means 24. So, may naiwan na isa, yung pang 25. We can show that 9 students have the same grade because the number of students is greater than the number of holes. So, yan, mapapansin natin sa A na meron na siyang 9 na students. Problem overview. Since 25 is equal to 3 times 8 plus 1, we were able to equally distribute the students into the letter grades. With 8 students in each letter grade, there was 1 student left over. Therefore, one of the grades must have 9 students with the same letter grade. So, why would teachers use the pigeonhole principle to teach students? It is for differentiation for grade levels, provides a visual to learn mathematical concepts, and improves problem-solving skills. So next is invariant principle. Generally speaking, an invariant principle is a quantity that remains constant during the execution of a given algorithm. In other words, none of the allowed operations changes the value of the invariant. So lagi lang natin tatandaan, pag sinabing invariant, it remains the same or hindi siya nagbabago or constant. Invariant in mathematics. Invariant in mathematics is a property held by a mathematical object which remains same even after repetitive transformation of the object. The invariance principle offers the hypothesis that metaphor only maps components of meaning from the source language that remain coherent in the target context. So, sabi nga kanina, invariant is constant, unchanging, specifically unchanged by specified mathematical or physical operations or transformations. So here is the example. A rook can only move along a diagonal. So, can a rook move from its current position to the question mark? Kaya ba ng rook na makapunta doon sa question mark gamit ang kondisyon na yung rook ay makakamove lamang into diagonal direction? So, sabi dyan, impossible. Why? Bakit nga nasabing impossible? So, the rook is in a blue position. So, mapapansin natin nasa blue nga siya na position. A blue position can only move to a blue position by diagonal moves. And the question mark is in a white position. So, it is impossible for the rook to go there. Kahit anong gawin natin sa pag-move sa rook, dahil ang direction niya lang is diagonal, hindi natin siya mapupunta ng question mark kasi yung question mark is nasa white position. So, yung problem na ito is invariant. This is a very simple example of the invariant method. So, next is principle of mathematical induction. Mathematical induction is a technique of proving a statement, theorem, or formula which is thought to be true for each and every natural number n, by generalizing this in form of principle which we would use to prove any mathematical statement is principle of mathematical induction. Mathematical induction is a method for verifying infinitely many related mathematical statements. In this section, we use induction to verify formulas for sums and inequalities. So, if we add consecutive odd numbers starting from 1, so yan, makikita natin 1 is equal to 1, 1 plus 3 is equal to 4, 1 plus 3 plus 5 is equal to 9. So, pag-add lang natin yung mga odd numbers. And 1 plus 3 plus 5 plus 7 is equal to 16. So, ayan, 1 plus 3 plus 5 plus 7 plus 9 is equal to 25. So, meron tayong 5 na odd numbers dyan. And ang equal niya is 25. And ang 25 is equal din siya sa 5 squared. And sa baba naman, 1 plus 3 plus 5 plus 7 plus 9 plus 11 is equal to 36. So, 6 na odd numbers yan. So, ang 36 is equal din siya sa 6 squared. So, two observations about the above formula. First, the formula actually consists of infinitely many statements or assertions, one for each number n. So, we claim that all the following statements are true. The sum of the first one odd number is 1 squared, or that 1 is equal to 1 squared. Sa susunod, the sum of the first two odd numbers is 2 squared, or 1 plus 3 is equal to 2 squared, or 4. So, next, the sum of the first three odd numbers is 3 squared, or that 1 plus 3 plus 5 is equal to 9, or 3 squared. So, the sum of the first n odd numbers is n squared, or 1 plus 3 plus ellipsis plus 2n minus 1 is equal to n squared. So, the purpose of mathematical induction is to be able to prove an equation works for all natural numbers, which are 1, 2, 3, and so on, without actually calculating each one individually. This is done by making assumptions on what has been proved in the previous calculation. So, next is argue by contradiction. To prove something by contradiction, we assume that we want to prove is not true, and then show that the consequences of this are not possible. That is, the consequences contradict either what we have just assumed or something we already know to be true, or indeed both. We call this a contradiction. So, here's the steps we follow when using proof by contradiction. First, assume your statement to be false. Second, proceed as you would with a direct proof. Third, come across a contradiction. And last, state that because of the contradiction, it can't be the case that the statement is false. So it must be true. So this is the example. No integers y and z exist for which 24y plus 12z is equal to 1. So, punta muna tayo sa original equation, which is 24y plus 12z is equal to 1. Simplify natin siya. So, divide both sides by 12, which is the greatest common factor nila. So, magkakaroon tayo ng result na 2y plus z is equal to 1 over 12, which is, yung 1 over 12 ay fraction. So, ito ang ating contradiction. Two integers cannot add together to yield a non-integer, aka a fraction. So, kung imagine nga natin, walang integers na pag pinag-add natin is magiging fraction siya. So, it means na no integers y and z exist for which 24y plus 12z is equal to 1. So, true ang ating statement. So, dyan nagtatapos ang ating topic about pigeonhole principle, invariant principle, principle of mathematical induction, and argue by contradiction. So, thank you!